On today's video, we're going to be refining some gold-filled jewelry. I have never done this before, but I really want to get set up. I'm not going to use the traditional methods of nitric acid. I have a new mad scientist approach that I want to try. So there's going to be melting, there's going to be pouring, there's going to be cupelling, there's going to be all sorts of stuff to try and get this gold out of this jewelry without using some of these really expensive ingredients that take a long time. So let's check this project out and see if it works. Cross your fingers, let's see what happens. We gotta get that bubbling to stop. I can tell you right now this is a bad idea. I'm just gonna go real slow. We might be onto something here. I'm here at Bellingham Coin Shop. Today we're gonna do some gold fill refining. So let's go in and meet RB and see what he's got for us.
So Jason, I have a huge pile of gold fill. It's been piling up for probably like a decade.
Wow.
There are out-of-state guys that refine this type of material, but I was hoping to keep it local.
Yeah.
And you being the local gold miner, I thought that there would be no better person than you to help me figure this out.
Well, I appreciate you calling me, and I am excited to tackle this. Some of that's sharp, huh? So, tell me a little bit about what gold fill is. This is not pure gold. This is not carat gold, or carat gold, is that the right
Right,
name?
it's not the stuff you refine, right? So,
yeah.
but in a way it kind of is, right? Because there's other stuff, other junk mixed in, right? So gold fill, like this is a pocket watch, right? So they would put a thick layer of gold. This isn't just gold plate, which is like microscopic amount of gold. This is a pretty heavy plate. Like if you scratch this on a stone and drop some acid on it, it's going to test as gold.
Yeah, okay.
But it's not, right? Well, I mean, it is. It's just a thick layer over like brass or copper or some other non-ferrous material, right?
Sure.
And it's made to use, right? This pocket watch would have probably a 25-year warranty that the gold was going to last.
Yeah, awesome. And so all of this, or most of this stuff, you've kind of hand sorted, and it's not gold plated. That's different than gold fill.
Right.
And so this is the heavier, thicker gold. How many ounces of gold here do you think? I mean,
I honestly, I don't know. There's about like 1 to 3% on any individual piece of gold, and some of this stuff is actually probably more pure than that. It might be up to 10% pure, but I don't know, right?
Yeah.
And I'm not the guy that knows how to. I'm not the chemist and the scientist. See, that's you. I watch you, and you're out there doing all kinds of fun scientific things.
Sure. Yeah, mad scientist.
Yeah.
Yeah. Can you explain a little bit about how to tell if it's gold fill versus fake or not gold? The beauty of editing.
A lot of times it's marked. Like on this piece here, there's going to be a 1/10 gold fill mark inside, and also. If you look at gold plate, it looks like kind of like pure gold, but it's very shiny and not the way natural gold will look, right? And this is a little more rose colored.
Yeah, gotcha. Could there be some stuff in here that is 14 karat or is 18 karat?
Absolutely, because
it just kind of all goes in a box.
Well, no, we sort all that out, but there's so much volume. Like, who's perfect, right? So there has to be some pieces in here. And whether it's just like something that's adorned with, like that could be 10 karat or 14 karat adornment that was added after the fact, right? Because we didn't test every little piece on this. So there's absolutely possible that there's, like if you wanted an estimate, let me get you an estimate.
Yeah, sure.
Now there's like 5 kilos of gold fill. So if we do the
2% or whatever the average is.
Yeah, that's a lot of gold still, right? So let's see, 5 kilos divided by 31.4, almost $15,000 worth of gold
in this box.
Yeah. I mean, it could be more too, right? Because that's 2%. So.
Yeah. Well, I think for me, I mean, you see my videos, I play around. I would like to do a test batch of this before I grab all of it and screw it all up. So why don't we weigh out, you can pick out whatever you want to, maybe up to 500 grams or 1,000 grams, whatever you're comfortable with. And I'll go do my mad scientist stuff and bring you back all the metals and show you what I got.
I like it. Let's do it.
Cool.
One of the things I like about scrapping gold-filled jewelry is sometimes you'll find people have actual gold necklaces and bracelets and the clasp breaks. And people don't always want to go to a jeweler, so sometimes they'll take old jewelry like gold fill, and they'll use like the clasp, and I've seen them put it on an actual gold chain. It was multiple grams.
Okay.
And sometimes you'll have actual karat gold, but then the stamping on like the clasp or the part they fixed ends up being just gold fill. So you don't realize the whole piece is actually gold.
Cool. So there's a good chance you're saying that there's some good karat gold in here.
Oh yeah, yeah. You definitely want to go through all of it. And one of the things that my buddy and I found is pocket watches generally have a relatively high amount of gold because it's big, solid, and they have usually the 25-year warranty, so it's a little thicker.
Like the covers.
Yeah, exactly.
Clasps.
And it's awesome because you've already gone through and taken all the actions out and everything, so that reduces the workload on processing. So that's my 2 cents on gold fill.
Wouldn't that be nice if it was 14 karat?
Yeah. Yeah.
All right, RB. Give us your best
All
or
right.
worst of it, whichever one you want to do there.
Well, you being the expert, what do you think? The pocket watch, is it because this is all new for you, so
It is. I'd like more of a smattering actually myself.
Just
like
blind sample, just grab and go. I mean,
rather than try and hydrate it.
Yeah.
It's just.
Look at that mess. Another thing I will mention is glasses. Glass frames for reading glasses. Those are generally high in gold as well.
Oh really?
But sometimes there'll be like stainless steel in there, so it makes it harder to process. Let's see. Pretty close to 1,000.
yeah.
Is that gonna work? Cool. Awesome. Well, hopefully I will be back shortly with a bunch of gold for you.
I'll see you in a few hours.
So here is our gold-filled jewelry. Now this stuff is typically heavy gold plate over jeweler's brass, so mostly copper and a little bit of zinc. Traditionally what you do is you dissolve this in nitric acid. All the gold foil stays because the nitric doesn't dissolve the gold, and then you can refine out the silver and copper later. The problem is nitric acid is really expensive, and you would need gallons to do this kilogram of gold fill I have. So I'm gonna try a new method. I'm gonna weigh out 50 grams of this stuff to do a little test with it. Let's go over to the smelting lab and see if we can make this work. All right, well, we're walking over and getting set up. Let me tell you about a couple of the issues with gold fill. It's only 5% gold at the max by weight. Usually it's more like 2 to 3. And that low amount of gold makes it very hard to recover by melting. You can't just melt it all down. Even if you electro-refine it away, you have the zinc problem and it poisons your electrolysis solution. If you try and melt it and dissolve it with acids, then you end up with colloidal gold, and it's so fine and small particles that you can't actually filter it or catch it. So that's the first thing we have to deal with, is figuring out how to get that gold into an alloy that we can then further process without losing any. All right, we're gonna try and get 50 grams worth here. I don't even know how much that's gonna be. Is that gonna be a lot? Oh geez. It's gonna be like 1 or 2 necklaces. I wanna diversify it as best I can so I can make sure I get enough gold spread out between the pieces. So let me grab a few different types of pieces here. Things like that. Shooting for about 50 grams. 44. Ring. Hopefully, kind of the holy grail is if you get karat gold in with some of this stuff. 50 grams. Okay, so if any of this is karat gold, it'll be significantly more gold. Like this ring, there's oftentimes a little stamp at the bottom down here. This was gone through by RB, so he knows what he's looking at. And I have a pretty high trust that he's got this all figured out. So there's our 50 grams of gold fill. Now I'll take you over and show you the next step. One of the issues with gold fill is that a lot of these little clasps and stuff are magnetic. There you go. They've got little pieces of steel in them, and if you use the nitric method, the steel really causes you problems. So I started going through and clipping off all this steel, if I can get a piece of it, because I was originally going to use the nitric method, but I hope this new method that I keep alluding to will work even with the steel. So I'm going to put a few pieces of steel in there, so our new weight is 53 grams. All right, we're going to take our 53 grams of stuff, put it in a crucible. Remember how I told you that if you melt it, you get colloidal gold? Well, I'm going to try a little trick here to avoid that problem. Let's go put it in our furnace. All right, I got to take out my other hot crucible here. I was doing something else earlier. Let's take it out. Put our gold fill in. So while that stuff is melting down, I want to explain a little bit about what the strategy is here. What we need to get is a clean copper, gold, silver alloy that we can then electrofine the copper away and be left with the precious metal mud. To do that, we need to get rid of the zinc. And there's not enough zinc in there to dissolve with sulfuric or hydrochloric acid. There's not enough molecules that would be available to the acid, so it would pacify the parts, right? So you can't dissolve the zinc that way. So I'm going to use a trick where I in-quart the metal with aluminum, of all things, which is kind of a no-no in the gold refining industry. But I'm going to in-quart it with aluminum because zinc and aluminum are amphoteric, I think is the right term. They are dissolved by a strong base, which we're going to use lye. Sodium hydroxide. The lye will then eat away the aluminum and the zinc, leaving a copper sponge that will be really clean, mostly copper, a little bit of gold, a little bit of silver, and then we can melt that down, a little bit of oxidizer to get that refined to a nice clean copper alloy. It'll get the lead out, it'll get the iron out, it'll get the tin out if there's any little tin with that oxidizer, and then we can take it over to an electro refining cell and electro win away that copper and be left with the precious metal mud in the bottom of our anode bag. I want to try this first step and see if it works. I'm going to use 50 grams. I don't know if it's going to work. I don't want to put our whole kilogram in there hoping this works. So in the next 10 minutes of the video, we should have a pretty good idea if this works. And if it does work, I know how to do the electrorefining and all the rest of this process, but I gotta make sure this aluminum step works first. So we're gonna add a little bit of borax to cover the melt because we don't want the copper and the zinc exposed to the air because it'll just oxidize. So we need to have a thin little film of borax on there. Once it's up to temperature and the gold fill has melted, I'm gonna plunge an aluminum bar down in there and it will alloy with the copper, and the borax should protect it from oxidizing. For 50 grams of gold fill, I'm gonna use 30, I think it's actually a 35 gram aluminum bar. Once I have it molten and alloyed with the aluminum, I'm gonna pour it into a bucket of cold water and cornflake it so we have a large surface area for the lye to start work on. Well, that did not work exactly like I wanted it to. I don't know why it was so clumpy. I know aluminum oxides tend to do that. I also noticed that when I pulled it out, the zinc was flashing off, so I got it too hot. But let's see what's in this bucket, and that'll tell us a lot about if it worked or not. All right, I'm just gonna decant this water off. I know I'm not keeping everything clean, and this is the proof of concept. I'm trying to see if this even works. So I'm not terribly concerned about all the other stuff that I'm not doing right. So I'm sure I'll get comments. Oh, that's what we got. Oh yeah. Ugh, sludge at the bottom. All right, what in the world do we have here? We've got aluminum. Yeah. It came out as clumps. There's some fines. There's some bigger, thicker things. I don't know if this is, maybe they're more like bubbles. Yeah, it's very brittle. AI helped me with this. They said the alloy, that the copper aluminum alloy I make should be very brittle and break, which it is doing. I should be, it said, let's see, it said I should be able to take a piece, put it on the table, hit it. Oh yeah, and it just shatters like glass. Okay. And that means the crystal structure has enough aluminum to where the lye should be able to eat it all and leave us with copper. All right, now what do I need to do? Next is we're going to mix up our lye solution. And I've got about 1 liter of water. Now we're going to add, looking for about 100 grams of lye here. Sodium hydroxide. Always wear gloves when you're dealing with sodium hydroxide. It'll eat your skin and your eyeballs. Hey, look at there. Pretty close. So we'll get our 100 grams of lye. We'll go mix that up with our 1 liter of water, and then we'll very carefully add our aluminum alloy to it. All right, we are way outside, way far away from the smelting furnace, because this reaction is going to release a bunch of hydrogen gas, and I don't want to be anywhere near anything that's hot or a spark or a flame or anything like that. So totally outside, stay downwind, all that kind of stuff. Let's start with mixing our sodium hydroxide into our water. This reaction is also very exothermic. It creates a lot of heat. So maybe a plastic container wasn't the best, but we're going to try it anyway. We're committed now. And I'm not going to add all the lye. I've got about a third or half of it in there. I just want to see what happens when we take one of our pieces of aluminum here and put it in there. That's anticlimactic, isn't it? It is starting to fizz on the surface. I can see that. So it is working. There, we're starting to get bubbles come off. So we're converting the aluminum to aluminum hydroxide. Yeah, look at that, it's working. Hot dog. We might be onto something here. Let me throw a few more pieces in. So all those bubbles are hydrogen. All right, we'll check back on this in a little bit. Yep, it's going. It's fizzing away. I hope those things turn copper colored. All right, correction. It's not aluminum hydroxide. It's sodium aluminate and sodium zincate is what we're making here. It's boiling away. We'll give it some time. Apparently, it's going to turn black. The copper surface will be black. It won't be orange or pink like copper looks like. So hopefully we have a black surface in there once it stops fizzing. It's been 2 days since I put the aluminum copper gold filled alloy in the lye. Let's take a look at what we got here. Well, they're still kind of looking like aluminum blobbies, aren't they? Well, let's add some more lye and water to it and see if it keeps reacting. It's not fizzing hardly at all right now. Let's see if we ran out of lye or if the reaction is done. All right, I added a little more water just so it doesn't get too thick. Let's see if I can kick this reaction off again by adding some more lye. Because if it starts reacting again, then we'll know the lye was the limiting reagent. I can hear it. Hear it foaming though. Yeah, there comes some bubbles. All right, didn't have enough lye. So I'm going to add in another 100 grams and let that go for a little while longer. Because we got to get that bubbling to stop. That's what we want. All right. Well, let's check on this sodium hydroxide aluminum thing I got going on. I was keeping an eye on this for a couple of days after I added the sodium hydroxide. I added a little bit more because the reaction wasn't happening the way I wanted it. And after 3 or 4 days of that, I essentially just gave up. And it's been sitting here for probably a month. And let me show you, it just didn't do it. It just failed miserably. It actually, there's like a crust down there. I don't know if that's the sodium hydroxide or what. You don't want to get that on your skin or in your eyes. But let's figure out another solution here. I've got a couple ideas I want to try with this, but first we got to clean up our sodium hydroxide mess. I got our solution decanted here. Poured off all the liquid, and we've got these like crystals in there. I don't know if that's sodium hydroxide crystals or aluminum hydroxide, aluminum oxide. I don't know what that is. But the cool thing about this is we're just gonna get it hot and melt it all down. That's what we're gonna do. When in doubt, use fire. That's what I always say. The cool thing about sodium hydroxide is to cancel it out. It's a really strong base. To cancel it out, you add hydrochloric acid to it until the pH is 7, and then you have salt water, sodium and chloride, and then H2O. So you got salt water that you can dispose of really easy. And then this stuff, because I'm assuming this is still a very, very, very strong base, I'm gonna add a lot of silica to this, as well as some borax and some potassium nitrate as a little bit of an oxidizer. And I'm gonna just melt all that down, get our 130 plus grams of gold fill and aluminum back in a blob, and then we can play with it and do something with it. So let me get that going. I'll show you a couple little steps along the way, but what I really wanna get is all of our metal back in one blob. Here's our slushy, gooey mess. I'm gonna add it back into the same crucible I melted the gold fill and aluminum together with. Again, don't get that in your eyeballs. We got our crucible full. I can tell you right now this is a bad idea. It's way too full. and it's wet, and I added potassium nitrate. So there's going to be a lot of gases coming off there as well as water vapor. I'm going to heat this up really, really, really slowly to try and get the gases to come up through first, not expand and melt and bubble through and boil through the system here in our crucible. And hopefully I can control the temperature enough to where it just dries out, starts to melt really slowly, releases the gas, and then melts down into a puddle. Cross your fingers, let's see what happens. I've turned it completely off, so I think that's just a lot of water we're boiling off. So there's just a ton of water in there. I'm just gonna go real slow. Well, that was kind of a disaster. I think I added too much silica sand and then it wouldn't melt. So I added some borax, then the crucible cracked. I kept seeing metal beads on top of the smelt. I don't know what I got in there. It's a mess. But let's let it cool, see if I got a metal prill at the bottom. I might end up crushing all that slag back up and remelting it in a clay graphite crucible, adding a bunch more borax, just seeing if we can get it fluid enough for everything to come out of the slag there. Boy, what a mess. Well, it's pretty mad, and I'm pretty mad. So we're gonna I just doused it. I just quenched it. I didn't even let it cool down hardly 2 minutes. It all bubbled up out the top here, lava like in Hawaii. But I'm gonna let that dry off a little bit. You can tell it's still real hot. Once it gets dried off and evaporates all the water around it, we'll dump it out. And I think I'm just gonna end up crushing it all back up. All right, we got work to do here. Let's see what we got. Can't be waiting around all day. Oh, we got the metal down there at the bottom. I did add some oxidizer. And so we may have oxidized some of the metal. Yeah, see. It shrunk when I cooled it in the water. It just pulled it right up. It actually doesn't look that bad. What's all this? Oh, look. Oh, that's a piece of my stir rod, my iron stir rod. So I don't know. I'm how do I feel about this? I don't know how I feel about this. The slag looks pretty good. There may be some leftovers in it. That iron there is going to be a problem with that copper. But I don't see enough beads in here to warrant melting it back down. There's a few, something in there. We're finding out what not to do here. But I think I'm not going to chase the little bit of gold. I mean, overall, if this works 100% great, there will be 4 grams of precious metals in here. About 2 of those will be gold. I'm not worried about a half a gram or a quarter gram or a tenth of a gram that I lost in here, because this was a test, right? So let's move ahead with what we have here with this mess and see if I can recover the gold out of this. Now I got to figure out how to do that. All right, I got the iron chunk off here. So I'm just gonna put that into my iron bucket and I'll use that for future smelts, and that'll reduce sulfides in the future. We're not gonna worry about that. We're focused on this guy. Now, it looks like two exciting things happened here. We got rid of the aluminum, it looks like, because that's copper colored now. And we also lost mass, I believe, a significant amount. I think we started with 100 grams of gold fill and I added 37 or some number to that. So we should have had 137 grams of metal there. I don't think we lost a heck of a lot of it to the beads in the slag. So we oxidized away a ton of metal, leaving us with 40 grams still to go. Now we got to figure out how to get the gold out of this. I'm debating about whether I want to do this, and I'm going to because it's fun and I've been thinking about it for a week or two to see if this works. What I'm going to do is I'm going to take our copper button, 40 grams, I'm going to put it in a melt dish, I'm going to get it molten, I'm going to add 10 grams of borax as a little puddle around this molten metal button. And I'm just going to let the oxygen work that whole metal bead into copper oxides, which will then be absorbed by the borax. And we're going to reduce that way down to a more manageable size that maybe I can cupel, maybe I can continue this process. I don't know. We'll see. I want to see if I can get rid of a bunch of the copper oxides using this method with borax. Let's try it. Sprinkle a little borax there. I don't know, that much. Maybe that much. There. That's the right amount. Now we'll get our propane burner over here. We are stumbling our way through, but I am really encouraged actually. Let me show you what I'm going to do now. We've got, still hot? No, not too bad. We've got blobs of copper, right? These are the ones that I ended up, where'd the other one go? Right here. It's not cleaned up yet. These are the ones I put in the melt dish. I got this piece is covered in slag, and I still have another little tiny piece of iron here. Copper's attached to it. Got a couple more pieces here. It's kind of a mess, right? It looks terrible. We got slag mixed in. I got all kinds of junk. But I have successfully reduced a bunch of copper down, oxidized a bunch of copper. Now what we're gonna do is I'm just gonna crush this all up. I don't know if I'm gonna crush it up. Maybe I'll crush it up a little bit. Mix it up with some new flux, melt the whole thing down again, pour it back in our cone mold, and that way we can end up with a nice, clean, fresh smelt where all the metal goes to the bottom like we want it. The slag will look really good, hopefully, if I do it right, know my chemistry. And then we'll end up with all the gold and silver concentrated in a little bit of probably copper at the bottom. And we will be able to cupel that or deal with that. So I'm on the final stretch here, but we got a couple more steps and we're learning a lot of ways not to do things, but we're also learning that the process works. We're just kind of stumbling our way through it. All right, we got 600 grams of junk. This is all of our slag, everything. I pulled the copper and stuff out. I'm gonna put that right on top. So now let me add 300, 400, 500 grams of new flux. There's 415 grams of new flux. Now shake it. I don't know if that works very well. Now into the crucible. Don't forget our metal pieces right on top. That'll allow them to get the maximum amount of oxidizer as they melt down through the flux. Now let's put it in the furnace. All right, well, first thoughts on that pour, it looked pretty good. The slag was nice and fluid. I thought I saw a little bit of metal come out there right at the end. We got that chunk of iron out of there at the end as well. So I have high hopes that we have a fairly small prill that we can knock off of that slag pyramid and get the last little bit of gold and silver out of there. Now, there's lots of places in this whole thing where we have had losses. The first crucible is full of junk still. The iron, you know, caused problems. That melt dish I had in that little scorification furnace, it wasn't working exactly quite like I wanted it to. This isn't trying to get all the gold and silver out. I don't want to prove that I can get 100% of the gold and silver out. I want to prove a process that works, and then we can, once we have that figured out, we can put that to the test and really get as much gold and silver as we can. Right now, this is proof of concept. All right, let's see what we got here. Best case scenario, we have a bead of gold and silver. Worst case scenario, no bead, but I'm expecting a bead of copper, smaller bead. Okay, you got some nice red on the slag. Can you see that? I don't know if you can see that. So there's copper oxide in there. All right, what's right here at the top? Okay. Well, that's interesting. Probably more copper than we started with. Which is fine. There was probably a significant amount of copper in the slag that we resmelted, so I'm glad we got all that back. Let me figure out what we got here. All right, we're back up to 36 grams again. But again, we started with 137 or something, so we've definitely oxidized quite a bit. 35, 37, somewhere in there. We're gonna try our scorification furnace again. This is more copper than I wanna deal with, but I also really, really want this process to work. So I'm gonna fight my way through it. I'm gonna learn a lot doing this. What I'm gonna do is 40 grams of copper is way too much to have a little bit of borax absorb as I oxidize it. So I'm gonna have to heat it up, let the borax do its thing, and then cool it down, pour the molten borax off, add some new borax, heat it up, let the copper oxidize some more, and I'm just gonna shrink that copper down, hopefully to a little tiny bead of gold and silver. It's gonna take a while. This is the learning process part, but ideally we can take our 35, 37 grams of copper and turn it into a gold bead. All right, we did our classic cornflake into water. It wasn't going as fast as I wanted, and it's just not sustainable with 40 grams. I think 10 grams you could probably do it, maybe 5, but not 40. So now we have a bunch of high surface area copper. I don't know how the slag looks. Black, I guess. A little bit of red in there. So we did oxidize some copper. It was working really well. I added a little bit of bismuth in there to see if I could use that to help it along, and it helped, but not the way I needed it. So what we're going to do is I'm going to take all this stuff, put it in a crucible with a lot of oxidizer, a little bit of borax, and we're going to see if we can oxidize a lot of it away with the second smelt, or a third smelt, or a fourth smelt. I don't know how many smelts we're on. All right, here we go. I got more oxidizer in here than I think we need for 100 grams, and we only got 35. But we're gonna do it. We're gonna get this gold, by goodness. We're gonna get this gold. Let's try it. Well, I saw a blob of molten metal come out of there, and it was bigger than I wanted it to be. So we'll see what happens when it cools down. It looks like the slag is a little blue-green, which is cool. Ooh. Hold on. Okay, what do we got here? Can you see the little pieces there on the table? They're kind of bluish. So that's cool. What's going on here? It's interesting that it's gray. I wonder if that's because I added that bismuth earlier in the video. Let's see how much it weighs. Where's my scale? Don't touch it, it's hot. Okay. 28. So that didn't work very well at all. All right, well, I'm tired of playing with this thing. I'm just gonna put this in a cupel, which you're probably not supposed to do with that much copper in there, but I'm gonna put it in a cupel. I'm gonna add about the same amount of bismuth, about 30 grams of bismuth. We're gonna start this thing cupeling, and I just wanna get the gold out at this point because I have another experiment I wanna try on another video coming up. So stay tuned for that one, but let's get this one in the cupel now. We'll see if we can get our gold out and see how much it is. Well, I haven't even put my bead in the oven yet. I'm already thinking about the next batch here. I've got all kinds of different magnetic stuff. We're still in the magnetic stuff, but I'm skeptical that it's actually gold fill, but then I started looking. Let's see if I can get this on camera. That one's sterling, but then that one, I think it says 1/20th 12K gold fill. Same with that one, 12K gold fill. This one says 1/20th 12K gold fill. This bracelet, which is very, very magnetic, 1/20th 10K gold filled. So either someone switched the clasp, or this is really, really heavy iron. Where'd my magnet go? I mean, it jumps right up to the magnet. It's very, very strong iron. These ones don't as much. Now I'm fighting the table. They're a little bit. But typically what I've heard is that you have gold fill over iron is usually either really cheap or the clasp got changed to make it look more expensive. But if that's really 1/20th gold fill, that means 5% of this is 10 karat gold fill. There's half a gram of gold right there in that bracelet. So depending on what happens with this bead in the cupel, I'm already setting myself up for another smelt, tweak it a little bit. But I wanted to show you with this camera that there's actually, it does say gold fill on some of this magnetic jewelry. All right, there we go. About half this copper button and half bismuth. Into the cupel. All right, here goes our beads. Do our copper first, and then our bismuth. There we go. We'll check back on that in a little bit. Hopefully we have a nice precious metal button. Take a look at our bead here. I had to add a little bit more bismuth because the button froze. I don't see hardly anything there. I don't see anything there. Maybe a little bit up around here on this edge, but not enough to weigh. So that's a bummer. Obviously it didn't work. I don't know how much gold I started with, but there's no gold in that cupel. So we either lost it along the way somewhere in the smelting process, or the copper in the cupel drew it into the cupel, and there wasn't enough gold to coalesce into a button. I'm not sure. It didn't work, but I've got another gold fill video coming up. I'm working on it right now that I have really high hopes for. So check back on that. Be sure to subscribe so you don't miss it. But thanks everybody for watching this video. We'll see you on the next one.